Yes, good evening students. This is our fourth class. In our previous class, we have completed about the phylum Porifera and Cnidaria. Now, today we are going to take first of all a minor phylum. That minor phylum is Ctenophora. Ctenophora. So, the name of the phylum is Ctenophora. Ctenophora. So, actually it is also a one type of the group in coelenterate. The coelenterates, yesterday we discussed that point. The coelenterates are classified into two types. So, that is based on the presence or absence of cnidoblast cells. Cnidoblast cells or cnidoblast or otherwise called cnidocytes. The presence or absence of cnidoblast cells, the coelenterata is classified into two types. That is, if the cnidoblasts present, they are called as cnidarians. Cnidarians. So, the cnidarians belongs to the phylum Cnidaria. So, yesterday we have completed that phylum Cnidaria. Now, the coelenterates without cnidoblast cells. The without cnidoblast cells, those coelenterates are called ctenophores. So, the ctenophores belongs to the phylum Ctenophora. Here it is a minor phylum. So, remaining Porifera 2 Echinodermata, they are all major invertebrate phyla. So, what is the difference between major phylum and minor phylum? Simple difference, that is the number of species, that is based on the included number of species. So, this is a minor phylum na, it includes the less number of species, that is why we can say it is a minor phylum. And one more is also minor phylum is there, that is in the track of Arthropoda, Onychophora. Onychophora is also one of the what? Invertebrate minor phylum. So, today guys, today we are going to take that minor phylum Ctenophora. Yes, see, ctenophores means these are the coelenterates without cnidoblast cells. So, yesterday we discussed the function of cnidoblast cells. Yes, in cnidarians, the cnidoblast cells perform three functions. One is defense, and second one is food capture, and third one is anchorage. So, the stinging cells is their other name. Here that type of cells are absent. But why the name given to that group Ctenophora? How the name will comes to this group, that is Ctenophora. See, first of all, the ctenophores, they are commonly called as, their common name commonly called as comb jellies. Common name comb jellies. They are otherwise called sea walnuts. So, another common name is also there, that is what sea gooseberries. Sea gooseberries. So, this is the common name for ctenophores. In Porifera group, we discussed about their common name. They are commonly called sponges or pore bearers. In cnidarians, they are commonly called jellyfishes. Here, the ctenophores are commonly called comb jellies or sea walnuts or sea gooseberries. Right? See. So, in Porifera group, what is the reason given to that group? Because the presence of pores. The phylum Cnidaria, the presence of cnidoblast cells. In that way, the reason for giving the name Ctenophora. See, in these they possess 8 external, 8 external rows of ciliated comb plates. So they possess 8 external rows of ciliated comb plates. The presence of these comb plates, hence they are commonly called as comb jellies. Hence the name given to that group, Ctenophora. Yes. What is their function? What is the function of these comb plates? Simply, these are helpful in locomotion. They useful in locomotion. Yes. One very important point is there regarding NEET. What is the speciality of the ctenophores? So, in our first class, I told one thing. Sponges all are marine. That means some freshwater animals are also there. Ctenophores, that is cnidarians, some freshwater animals are there, remaining all are marine. But the exclusively in the sense 100% these are marine. And echinoderms also, ctenophores and echinoderms, these are exclusively marine. That is very important point. So ctenophores are exclusively marine. So there are no freshwater animals in this group. They are exclusively marine. In your entrance examination, he will ask a question. In which of the following are completely marine habitat? They live in marine habitat. So they will give one option, for example, ctenophora. Second option, echinodermata. Third option, both 1 and 2. Yes, that's our correct answer, because echinoderms and ctenophores, these are exclusively marine. This is very important point. The same word we can repeat in the phylum echinodermata, not other invertebrate phyla, because in other invertebrate phyla, some are brackish water animals, some are terrestrial, some are freshwater, like this. But these are exclusively marine. This is very important point, right? So some common characters are occur between the two groups, ctenophora as well as cnidaria. So here I'll give some common characters, because both are belongs to coelenterata. Previously they are called coelenterates. What are the common characters? See, I'll give here the common characters about cnidarians as well as ctenophores. What are the common characters? I'll give 1. So both are diploblastic animals. Both are diploblastic. That means their body wall possess 2 layers, outer ectoderm, inner endoderm. That's why they are diploblastic animals. Diploblastic nature means outer layer of the body wall is ectoderm, inner layer of the body wall is endoderm. So obviously between the ectoderm and endoderm, mesoglia is present, but in sponges that is mesohyl. So here in ctenophores and cnidarians, mesoglia is present. So diploblastic nature is a common for both cnidarians as well as ctenophores. Alright. Next, one more common character. Both will show tissue grade of organization. Both tissue grade of organization. Yes, in our yesterday's class we discussed about the first time in the animal kingdom nerve cells and sensory cells are appeared in coelenterates, that is cnidarians. So this also one group of coelenterates. That's why the tissues are present. So they exhibit tissue grade of organization. That is one common character. Next, one more common character in both the digestive system is of two ways: intracellular digestion, intracellular, and extracellular digestion. So that is a common character for both cnidarians as well as ctenophores. So one more common character, that is both will exhibit radial symmetry. Yes, regarding symmetry, one exemption we discussed in yesterday's class, except Adamsia, that is commonly called as sea anemone. Only in sea anemone is the common name. Adamsia is its scientific name. Only in Adamsia biradial symmetry is there. That is one exemption. Except that sea anemone, remaining all they exhibit radial symmetry, both radial symmetry. And one more common character, the development is indirect. Development is indirect. So indirect development, that means the presence of larval stages. In both of these, the development is indirect. The larval forms are present. Yesterday we discussed in cnidarians, the common ciliated larval form is there. That is planula. Once again I am repeating about the larval stages of the previous groups. In sponges, amphiblastula, parenchyma, trichimella. These are the three larval stages of sponges. In cnidarians, the common ciliated larval form is planula. In ctenophores, the larval form is cydipid. So I'll come after 2 or 3 minutes, reproductive system. In that way we can discuss about the larval stage. So these are the common characters regarding cnidarians and ctenophores. Right. Now, what are the special characters? These are common for both cnidarians as well as ctenophores. Now, coming to the special characters, they are related to, they are subjected to only ctenophora. What are they? So we will discuss now. See, one important point is, in ctenophores, 8 rows of external ciliated comb plates. 8 rows of external ciliated comb plates, they are useful for locomotion. Okay, right. That is one important point. And one more special character for food collection, for food capture, one type of specialized cells are present. What are those special cells? See, glue cells. They are otherwise called lasso cells. They are otherwise called colloblasts. So these are the special cells present only in ctenophores. But what is their function? How they will useful for ctenophores? Simple thing, they are useful for food capture. For locomotion, 8 rows of comb plates. This is a special character about the ctenophores. And for the food collection, the specialized cells are glue cells, or lasso cells, or colloblasts. That's one important character. And one more is very important character. They exhibit bioluminescence. Yes, very important aspect about the bioluminescence. Right. What is bioluminescence? I'll define. We are all living organisms. The ctenophores also living organisms. But what is their speciality? You know well, firefly. They emit light. The firefly is the best. That is our familiar example. Firefly, that is a living organism that can emit light. So the emission of light by living organisms, that is called bioluminescence. Once again I will repeat, what is meant by bioluminescence? The bioluminescence is otherwise called as living light, or it is otherwise called as cold light. Bioluminescence is a technical term. Living light, simple term, common term, and cold light. So what is bioluminescence? So the emission of light by the living organisms. So that is what bioluminescence. So in entrance examination, he will ask a question. What type of question it is? Which of the following? They will give 4 options. First of all, the question is, which of the following are bioluminescent organisms or exhibit bioluminescence? I will give the first option, pyrosoma. One option is pyrosoma. Second option, jelly fish. Third option, squids. Right. Suppose jellyfishes and squids. So I'll give these 2 in one option. And third option, ctenophores. Fourth option is all the above. Yes, our answer is all the above. Not only the ctenophores, pyrosoma is also exhibit bioluminescence. Right. What is pyrosoma? It is one urochordate. Yes, in the chordata phylum, that was classified into 3 subphyla: urochordata, cephalochordata, vertebrata. So here pyrosoma is one urochordate, that is otherwise called a tunicate. Then coming to jellyfishes, cnidarians, Aurelia, Rhizostoma, they are jellyfishes. And squids, one type of molluscans. And coming to our ctenophores, that is a very important point regarding NEET. Next, coming to reproductive system. One more special character about the ctenophores that can differ from the cnidarians. Yesterday we discussed about the reproductive system of cnidarians. They can reproduce both sexually, asexually. But in ctenophores, only the sexual reproduction occurs. Very important point. They reproduce only sexually. There is no asexual reproduction in ctenophores. This is a different character from the cnidaria. They reproduce only sexually. Yes. Now, so ctenophora. Just now we discussed about the common character of both cnidarians as well as ctenophores. That is, development is indirect. That means larval stage is there now. So what is the larval form of ctenophores? The larval form is cedipede. Cedipede is the larval form. Cedipede. So once again I will repeat all the larval forms. Regarding sponges, Amphiblastula, Parenchyma and Trichomella. Cnidarians, Planula. Then ctenophores, cedipede larva. So example, Ctenophora is the minor phylum na. It includes the less number of organisms. So among these, only I'll give two examples. One is example Pleurobrachia, Tenoplana, Hermifora. These are all examples. So this is the information about the minor phylum Ctenophora. What are the common characters related to the cnidarians? What are the different characters, dissimilar characters related to cnidaria? And what are the special characters that are particularly confined to Ctenophora? That is our content. Next, go for next another major phylum, that is Platyhelminthes. So next phylum is Platyhelminthes. Yes, my dear students, about the Platyhelminthes phylum, we can learn about some peculiar character. They starts from this phylum, that's Platyhelminthes to Echinodermata. All these characters comes in somewhat different way. So what are those different characters related to Platyhelminthes to Echinodermata? So first of all, we can take the name of the phylum Platyhelminthes. Right, Platyhelminthes. See, these are commonly called as flatworms. What is their common name? Flatworms. Sponges are commonly called, Porifera group is commonly called sponges. Cnidarians are commonly called jellyfishes. Ctenophores are commonly called as comb jellies. Here, the members of the phylum Platyhelminthes, they are commonly called as flatworms. Why we can say about their flatworms? Simple. First time in their body organization, dorsal surface, ventral surface, these two surfaces are appeared. So the dorsal and ventral, their body was dorso-ventrally compressed. Hence the body looks like a flat, hence the name flatworms. Platy means flat. So that is the reason the name given to that group, Platyhelminthes. Right. Who coined the term Platyhelminthes? Gegenbar. Yes, in our previous class we discussed about the name of the scientist. Phylum Porifera by Robert E. Grant. Phylum Cnidaria by Barnes. Phylum Coelenterata by Leucart. Here it is Gegenbar. Platyhelminthes. Yes. See, first time we are hearing about the word. Platyhelminths are mostly endoparasites. The parasite means for food, for shelter, for any other aspect that depends on other organism. So depends on other organism, that organism is called a parasite. The parasite which lives inside the body, those are called endoparasite. Mostly endoparasites. That means some free living organisms are also there. So the free living organisms are turbellarians. Turbellarians are the free living flatworms. This is very important point regarding entrance examination, because they're not completely parasites. Mostly, just the word, refer the word mostly, not all, because in this phylum Turbellaria is one of the classes. The turbellarians are not the parasites, they are free living. Hence they are commonly called free living flatworms. Right. See, now the flatworms, the characters about the flatworms. See, these are first triploblastic animals. Yeah, this is a new word for us. We discussed in Cnidaria as well as Ctenophora. They are diploblastic animals. Diplo means two, blast layers. Here these are first triploblastic animals. Triplo means three. So their body wall possess three layers. Already we know the two words, outer ectoderm, inner endoderm. First time in the animal kingdom, in this phylum, mesoderm is appeared. So first time mesoderm is appeared in this phylum. Hence, Platyhelminthes is the first triploblastic phylum. So from Platyhelminthes onwards, all are triploblastic phyla. The first triploblastic phylum is the Platyhelminthes. So see, one important point, in sponges we discussed about the mesohyle, that is between pinacoderm and coenoderm. They are not the true layers we discussed in our earlier class. In Cnidarians, mesoglia between the ectoderm and endoderm, but in flatworms, mesoderm. See, mesohyle, mesoglia, mesoderm, mesohyle in sponges, mesoglia in Cnidarians, mesoderm in Platyhelminthes. So first time the mesoderm, this is the third germinal layer. The third germinal layer is the mesoderm. First time is appeared in the phylum Platyhelminthes. So that's why Platyhelminthes is the first triploblastic phylum in the animal kingdom. Right. So one more special character, speciality. So what is that? So yesterday we discussed about the symmetry, but in Platyhelminthes, bilateral symmetry. All they exhibit bilateral symmetry. So ctenophores and Cnidarians, they are radial symmetrical animals. Radial, but here the bilateral symmetrical animals. What is meant by bilateral symmetry? Bi means two. One animal can be cut into two equal halves. These two equal halves, they with all similar organs, similar structures, symmetrical. That is what bilateral symmetry. So these two equal halves are called antimeres. So first time these are bilateral symmetrical organisms. And one more important point regarding level of organization. Level, sponges, cellular grade of organization. In Cnidarians as well as ctenophores, tissue grade of organization. But in Platyhelminthes, their organ system level of organization. Organ system level of organization. And this is the first protostomian phylum. What is meant by protostomia? Blastopore is converted into mouth. So that's why they are called protostomians. Echinodermata onwards, the deuterostomians. That means phylum Platyhelminthes to mollusca, all are protostomian phyla. So what is meant by protostomian phyla? Blastopore conversion into mouth. That's why these are what? And one more important character, that's the last one, today's class. This is a coelomate phylum. A means absent. Coelom means body cavity. What is the coelom? I'll give one definition, simple definition. For example, this is one organism. Here this is the body wall. This is the alimentary canal, that is gut, alimentary canal. So the space present between the body wall and gut, that is called coelom. So in a transverse section of the organism, this is body wall, here it is the alimentary canal, that is gut. This is the space, the space present between the body wall and gut, that is called coelom. But in platyhelminthes group, there is no coelom. Coelom is absent. Why the coelom is absent? Simple thing, the total space is occupied by one type of tissue. The tissue is